Okay, good evening, good evening, good evening. I hope you can all hear me. If you can, just let me know in the comments, please. Thanks for joining us, by the way. Hello, can anybody hear me? Hello. Okay, so good. I think we have live here. So we are using the SEESTAR S50 smart telescope tonight. This is the first chance I've had to try and connect it up to the PC to try and get some images going. Now, the problem with the SEESTAR is that it doesn't have a native PC program for Windows. Everything is done either on an iPhone or an Android, so I've been working to try and connect the Android phone to Windows. Not easy, but we're getting there. So at the moment we're trying to just connect this, and at the moment, yeah, obviously you can see the moon is tracking the moon. We are hoping to do a bit of astronomy when it gets a bit darker, probably in about half an hour. So the skies, it's getting there, it's just not dark enough. There's no stars visible just yet. Give me 1 second. The screen has just gone on my phone, has just gone green, so that's not a good sign. Okay, so we're back with that is the view of tonight's moon. Now it is only a 15mm telescope, which is quite. Some of the views are actually really good, particularly with the full moon. I can previously, I think you'll see it in one of my videos. Some actually quite decent video. Now the problem is when you're doing a viewing the sun or viewing the moon with the SEESTAR, you can hook it up via the VLC video player. It has an RTSP signal, which is what we're seeing at the moment. The problem is once you go to doing any deep sky astronomy, you can't do this type of live viewing. So yeah, this is where you have to connect your phone to the PC to see the phone on. Anyway, it's a pain in the backside, but I think I've got it worked out. We'll soon find out once it's dark enough. But at the moment, we've got some nice views of the moon. Can actually try and increase the size. I'm going to try and double this up. Let's see what happens here. We could break the whole thing. I'll bring that down a bit. Oh, there we go. Hopefully that will update itself very shortly. I am trying to read what. Oh, I have kind of overshot the mark. Up a bit more. Hopefully that's it. I am trying to read the comments as I go along here, so forgive me. This is the first time using this, so it is going to be a bit hit and miss. Now this is scaled up image. Now in Facebook, if you look up SEESTAR S50 or say WO SEESTAR, I think they have an official group, you'll see some of the images that have been able to be taken with, and it is quite impressive for such a small scope. And now I have tried astrophotography in the past, and it is such a pain in the arse. It really is. You know, particularly when you're trying to when an equilateral triangle telescope, and you're trying to get good enough images that you can then stack together to get the final image, and it is just, it's very long-winded. The great thing about smart telescopes is that they do it all for you. Now you can actually capture the raw images, take it to your PC and play about them with them to your heart's content, or you can sit and hopefully, fingers crossed, what we're going to do tonight is that the telescope did all the work for us. We will basically tell it where to look. It will then begin to stack the images and should give us a view of parts of the night sky, and we'll hopefully learn something as we go along. We'll find out what facts we can about whatever we're looking at. So as I say, probably about 10:15 UK time. It's in about 15 minutes. So hopefully it will be dark enough for us to have a look at the night sky. But at the moment we've got a nice view of the moon. I think it's about 30% illuminated tonight. If you look at the dark patches, obviously that's the mares, the great seeds of the moon, the small round one there in the middle. Oh, that's Mare Crisium, the Sea of Crises. Yeah, unfortunately it's a bit, the feed seems to be a bit blocky tonight. I'm not sure why. It was working great earlier on, of course, because I had tested it, but that's the way it goes. Yeah, and of course it just overshot the screen. But we're getting there. Say for our first night out, it's not bad at all. And say if you do look at one of the previous videos, where it was the full moon and everything was working. I didn't do anything else other than the full moon that night, and everything seemed to work very well. But for basically a telescope which you just set up and walk away from, it's and it just finds the moon without any problem. So just below Mare Crisium, you see the larger dark spot. My PC's beginning to doesn't like everything I'm doing on it. If I can click a few more times, hopefully we'll get it. No. Sorry, its OBS is beginning to freeze up, so hopefully you will still be able to see and hear me. I think it's working. Right, here we go. Okay. So, nice view of the moon. When it wants to work. And that crater, which you can see. I'm not sure if my mouse is meant to be showing up, but I don't think it is. But there's a little crater just about 2/3 of the way down the screen there. That is Langrenus, and it's on the eastern edge of Mare. I'm going to try and pronounce this, but good luck to me. In fact, I'm not sure how you say this without swearing. Facuntatis. Okay, I obviously didn't get that right at all. So that little crater just there, it's 132 kilometers in diameter, and it's a depth of around 2.7 kilometers. And it's thought to be 1 billion years old. What we will do one night is just actually look at the moon and do nothing else. I can actually hook up, I do have a larger telescope. I've got a couple of telescopes, got 130 millimeter Newtonian, which gives some nice views. I do have a 10-inch Dobsonian, which I haven't used in a long time, simply because it is a pain in the backside to lift in and out of the house. But that does, once you get that up and going and get it focused properly, you do get some really, really good views of the moon. So we will do that some night. We'll do a moonlight and we'll see what we can see on the moon. The problem is, of course, we're coming into summer, and while you have better nights, clearer nights, unfortunately it doesn't get dark till quite late. And say here it is just after 10 o'clock. We're probably going to wait another 10-15 minutes, and then we'll have a go with the actual phone software, and it comes with the SEESTAR, which I have tested it and it does work. For such a small scope, I mean, it really is like a box of cereal, the size of it. For what it can do, it is quite incredible. I'm very pleased with it. So I just might as well say hello to everybody. I see it all on the screen. So here we've got Simon, Anthony, Kenny, Linda, Christina. So I haven't got my glasses on, so you'll have to forgive me if I can't see some of your names. Carlo, Mark, and Eva Luna. Oh, hi Eva, back again. So hopefully in about 10 minutes we'll be able to get this up and running. It's just a shame that the connections seems so bad tonight. I am going to try and connect. Give me 1 second. I'm going to try and connect the phone up and see what we get from there. Let me see if I can remember how to do this. Okay, so hopefully should be back again, almost back again. Can you hear me? You probably can't see me just yet. Let me see if I can get that to work. For some reason it's not coming up. Okay, so that's not what we want, but we're getting there. So if I go to this, fingers crossed, there we are, we're back in business. Okay, so what we're seeing on this is what I actually see on the phone, and this is what we'll be using tonight when we actually do some proper astronomy. So that's it. This is the app on Android, and the iOS one is more or less the same. So it allows you to center the target. So we're looking at the moon. So if I click on this, the telescope will do its best to center the target. I can adjust different things, brightness, exposure, gain, blah blah blah. I'm just going to keep it obviously on auto focus, and you click on focus and you double click on whatever object you're viewing. The telescope will go through a little routine and hopefully focus the object for you. You little option for a joystick, which you can move things up and down. And we'll just put tracking back on, obviously. And that's that. There was a way to view the screen without on it. Let me see. Full screen mode, is that what it is? Yep, there we go. So a nice, on the phone, obviously with a smaller screen, it looks very good, but I think that's not bad given that it has been enlarged somewhat. You're getting a nice view of the moon, and that is actually enlarged itself. And you can see the telescope there is actually keeping the moon centered. So basically you turn it on and you walk away, which is great. And no heavy telescopes to lift, no additional cameras. Everything is done over Wi-Fi, which is good, but also having a cable could be better, simply to give you a more stable connection. But so far, things seem to be working. Fingers crossed. And I say in probably about another 5-10 minutes, we should be able to get up and running and hopefully see what the night sky holds for us. Look at all those lovely critters. Oh, it's just slipped there, and there's the telescope bringing it back into view. So I'm just checking on the Facebook site here. There is a program called Femix that I have, which actually will let me a few comments from both Facebook and YouTube at the same time, which would be good. So I might actually have to bring out some night. So hello everybody. So hello. Say, is that B-Boys? Isaac, Mr. Banix, Buana. Hope I haven't missed anybody out. So say maybe in 5 or 10 minutes or so it should be dark enough for us to hopefully have a look at the night sky. We're in the northern hemisphere here, so if you have any particular targets you think we should look at, listen, also you have to be realistic with this scope. It is a 50mm, 2 inches in size, so there's not a lot of glass there to work with, but given the size of the scope, I think it does a marvellous job. So another couple of minutes and then we will crack on and hopefully see what we can see in the night sky. You probably heard me taking a drink there, a big gulp, I know. But I am very impressed. I think that is a great view of the moon, I really do. And we will do a moon night where we will actually just sit and no B-Boys, we will be looking at other things. We're just waiting on it getting a bit darker out here. Unfortunately, with coming in the summer, it doesn't get dark till quite late. I think hopefully in another 5 minutes or so, we should be able to look at some objects in the night sky. The moon is just there to keep us occupied. In fact, what we'll do, we'll have a go. So, I'm going to skip out of this. So you'll see everything that... So there's the main screen as it appears on the app. So what we want to do is go into Stargazing, and best right now. I'm assuming you can you see that? It's giving me some options as to things to look at tonight. So we're going to go up to best right now, okay? And M13, Great Star Cluster. So let's see what I can find for us. And while it's doing that, I'm just going to look at some facts for M13 so I can amaze you with my astronomical knowledge. Messier 13 in Hercules globular cluster. So what is going to happen? As you can see, the camera is working away there. So the telescope is trying to find it first of all. Again, if it may not be dark enough for it to find that particular object just yet. So hopefully it will come across it. If not, we'll pick another target. Oh, there we go. So what it's going to do, you'll see if I can shrink this down a bit on screen. So what the telescope was going to do, it's sorting out its calibration, ensuring it knows where it is and it's pointing at the right object. And there you go. It's going to start taking a series of pictures. And it looks like it's looking through some wires or something. But yeah, there's a bit of like a fence close to me. It's just picked up one part of the next guy. We'll see what happens. Sometimes it will reject when it sees things because it might think it's a star trail or a plane going through, but we'll see what happens. It's still trying to calibrate as to where it is, and unfortunately a fence isn't helping. We'll give it another minute or two to see if it can actually find the object. It's certainly thinking about it. Yeah. So it's trying to calibrate itself and it failed. Not a good start. I say when I tested this the other night, things were working. Oh, there we go. Okay, so here we go, hopefully. And what it should do is start taking a series of images, and then it will start basically adding each image to another and taking out basically the best parts of each image that it thinks is relevant, and at the end of it you will have a much better image than just one particular shot. And that's what the astronomers do. Just if they were doing it themselves, they would sit all night, they would have their telescope pointed at a certain area, they would take hundreds if not thousands of particular images, but then they bring it back into their PC and work on it from there. And you can do that here. You can keep all the raw files, bring it back into your PC, and then play with it to your heart's content. I'm going to be honest, I can't be bothered with that. I really can't. I'm sure it's very interesting, but it's not for me. So I do like this. This is a setup and just let go. Now there are a number of these smart telescopes. There is one by Celestron, I think, which looks quite good, but it's like $4,000. So out of my price range, this I think is about 500. There's a smaller version called the S30. Okay, so this is where it begins to take different photos. Now these are only 10-second images. You can set up the telescope on an equatorial mount, which I will do. That will stabilize it. Anything over 10-15 seconds, what happens is you will begin to see star trails, simply because obviously the Earth is turning and the camera's not. So as you see, that second picture is slightly different from the first in terms of the position, so the telescope will have to adjust for that. Now I would certainly look, if you want to get into astronomy and astrophotography, if you want to spend the time processing all the files yourself, go for it. But you will need a decent mount. You will need a decent telescope. I think for a 50mm 2-inch lens on this is just quite phenomenal with the stuff it's coming up with. As you can see, it's ploughing away there, and it will take image. Some people leave their telescope running all night. You can actually also set a plan, so you can actually have a look at, say, this cluster, and then maybe in 2 hours time you can actually tell it to go and look at a nebula or something else. So with that, plodding on, and we'll come back to that. So we'll have a look. What do you know about Messier 13, the great globular cluster in Hercules? So who do you think discovered it? Edmund Halley, and of course he's discovered something else, if you know what that could be. And it was Charles Messier put it into his list of objects not to mistake for comets. So it's about 1/3 of the way from Vega to Arcturus. 4 bright stars in Hercules form the keystone asterism, the broad torso of the hero. M13 can be seen in this asterism. So what is an asterism? Obviously we think of constellations. I think it's the Plough, or the Big Dipper, is an asterism. It's not actually a constellation. Basically it's a set of stars that are familiar directly to the, when you look up in the sky, and I think the Big Dipper is probably a good one, but that's part of a wider constellation. Let's see how many, it tells us how many stars are actually in this cluster. So it's about 145 light years in diameter. If somebody wants to work out in the miles, go for it, and then put it in the comments. We'll see where we are. I'm just going to have a look back here, because I actually can't see what's going on. So we can play about with this and zoom in a bit. And as I say, what you would normally do is leave this running for hours and hours, and then come back to it, and all these different photos will take out a lot of the noise. It'll fix any aberrations that are in it, so you actually get the best photo possible, certainly with a 2-inch telescope. So the brightest star in the cluster is actually a red giant. It's a variable star known as V1554 Hercules. Okay, I'm just trying to find out if we know how many stars are in it. Well, that didn't tell me. Let's see here. And can't actually find out the number of stars that they think is in it. Ah, there we go, found it. So they think it's up to 500,000 stars. I'm not exactly sure, anywhere around 300,000 to 500,000. And that in itself is about 100 times more than you can actually see with your naked eye on any night sky. So where we are here, yep, there we go. 145 million light years across from end to end. That in itself is staggering. And remember, apart from really the Andromeda Galaxy, everything you see in the night sky is within the Milky Way. So what I'm going to do, I'm going to pop out of that, so we'll just stop that. And there you go, it gives you, and that's only a couple of minutes of imaging. So we're going to probably do that, back to stargazing. Not M51, Whirlpool Galaxy. This, hopefully, if we can get this, make my night. And again, if you search for the SEESTAR Facebook groups, you'll see some cracking images of this. And I say, to make this sort of astronomy so accessible, and not cost money, everything costs money, even buying a decent mount costs money. If you are going to do astrophotography, you know, for the price of a mount, you're getting, I think, a good value telescope, a smart telescope that's doing all the hard work for you. So we're looking for M51, the Whirlpool Galaxy. So I was trying to identify where we are here. Oh, I think it's found it already. So well done, Ed. Just trying to connect something up. So hopefully that has found the Whirlpool Galaxy, and it's beginning to, yep, it's beginning to stack the images. So I'm trying to do 5 things at once here, of course I am. And none of it is actually working, so. Okay, let's see what we got here. Stacking failed, I wonder why. Again, cubing, this maybe's not dark enough out there. So let's see what happens here. Okay, so it's beginning to stack a couple. I did, this was my test shot I did the other night, and Stargazing, I'm not sure what is happening, because it did work very well the other night. I will try and have to get the equatorial mount going, see if that stabilizes things a bit more, maybe gives an extra few seconds, because when you're doing astrophotography, it really is down to the amount of light you can capture. The more light, the more detail, the less noise, and that's going to end up giving you a better picture. But it's chugging longer. I say you will have to normally let this run, I would say, for at least half an hour to get something decent, but we'll let it go for 5 minutes or so. And while we do that, well, we'll see what we find out about the Whirlpool Galaxy. So it's known as Messier 51, M51. And of course, Messier, his name's Charles Messier, who created his catalogue of astronomical objects. Now, can't see Iran from the UK at the moment. Unfortunately, it's just passed beyond our horizon. It's headed southward. I wish I had been able to take some images not only of Orion. You have Betelgeuse, of course. You have the Orion Nebula, which is a great target. So we'll have to wait probably to October, November time to be able to do that. The Whirlpool Galaxy, it's known as a grand design spiral galaxy, and simply means that it's very well defined and prominent spiral arms. Now it does have a companion, you'll see it as this image forms. You'll see the main galaxy, and then to the side of it there's a smaller galaxy called NGC 5195. That's behind actually one of its spiral arms. And the M51 is about 31 million light years away. So the globular cluster we looked at was 145 light years wide. This galaxy is 31 million light years away. So even travelling at the speed of light, it's going to take you 31 million years to get to. And it was William Parsons, an Irish astronomer in 1845, that identified it. He's got a telescope called the Thathan of Parsonstown. I actually seen it. It's quite very, very impressive looking telescope, certainly for at the time. Now, I thought that M51 is actually still very active in terms of star creation. There's been observations that have seen lots of pink nebulae, blue star clusters, and that's meant to indicate that stars are still being born there. So it's a galaxy that's very much alive. And of course, as you can see, it is beginning to take shape here. And on a 2-inch telescope, 50 millimeters, and this is just what, 3 or 4 minutes of observing. If you were to let that go all night, you will get some cracking images, and say you can take those files, you can bring them all into your own PC, and you can play with the files themselves to your heart's content, as other people do with astrophotography. But I just can't be bothered with that. This is great for me. This lets me see the night sky. This lets me to enjoy it from the. Finally, I've got it working, so I don't actually have to stand up with my phone. I can put on a big screen like this. One thing I would say to SEESTAR, I think that's ZWO, is that if you need an app for the PC, an app that's going to allow us just to connect it directly to the telescope, because I have jumped through a number of hoops to be able to put it via OBS tonight. It's not impossible, it's just a pain in the arse. It really is just a pain in the arse. But as you can see, it's beginning to take shape. And you can go out there. I wonder if I can find one professional. Give me a shot. Now, obviously this is never going to compare. So I'm just going to upload a Hubble image here of the galaxy, simply because it's bloody impressive. It's good, certainly one of my favourites. Let me see if I can find it. Where did I save it? There we go. This is from Hubble. And of course you are going to see a bit of a difference between the two. Look at that. I mean, that's the Hubble telescope, and it's obviously many, many times greater the size and it's above Earth's atmosphere, so it doesn't have a lot of the aberrations that you get when you're viewing from Earth. But what a beautiful spectacle it is. And this little companion galaxy there beside it. But hey, for a 2-inch telescope, I am actually so impressed. I really am so impressed. And it's doing all the work for me. And it's still adding screens. So there's been a total time there of just 4 minutes. If you are getting into astrophotography, you're looking at hours, not minutes, hours to get a great photo. And I think this little telescope, which is it is like the size of a cereal box, is doing so much good to get people interested again in astronomy. Because it is point and shoot, and say there are other options. There's the S30, which is from the same family, but there's, I think one's called the Dwarf 30, is that one it is? It's a different make, but the one I have my eye on, and Celestron, if you want me to try it, I certainly will. I can't remember what it's called, but it is certainly a bigger scope, and I would love to get my hands on it, but it's $4,000, so that won't be happening. Yeah, galaxies are great to see, it really is. Simply because they're so blooming large. And I say, had it been earlier in the year, we could have probably caught the Orion Nebula, which should have given a good view as well. It is one of the things that, even with a camera, if you have a decent camera, you can get some nice photos of the Orion Nebula. So a couple of other things we will be doing, obviously we're looking, this is just the first go, make sure everything works, which it does. We'll be doing just stars. You know, our sun is a very basic star. You take something like Betelgeuse, giant red, which is in part of Orion. Betelgeuse is so big it would reach from where our sun is out to probably Jupiter. You know, totally different type of star, you know, and it's a star that could go supernova. There's people who say it's due for going supernova anytime. Others say it could be anytime in the next 100,000 years, so don't hold your breath for that. But I am very impressed with, here we are, not even 5 minutes in. It's quite clear, you can see the structure of the main galaxy and also its little companion galaxy. And what I will be working on setting up the equatorial mount. That will mean we can actually extend the capture time from 10 seconds to probably 20 or 30. So you're gathering more light, more lights, more detail, and it's going to build that image up a lot faster. There are also built-in filters to the telescope, which I think I'm hoping it does it automatically. So if you're living in an area which has a lot of street lights, for instance, one of the filters will help cut through that. So back to M51, it's about the size of the Milky Way, about 76,000 light years across, and it's slightly smaller than our own galaxy. It's part of a larger group of galaxies. So it's I didn't know this. It's a type SABC galaxy. Now, in the Hubble sequence classification, M51, it means it's a moderately wound spiral structure and a small bulge. There you go, moderately round with a small bulge. So we found a Hubble Space Telescope. Apparently it's been viewed by the James Webb. Doesn't surprise me. It's been viewed by the James Webb. Must look that one up as well. So I'm just asking my friend in ChatGPT for any little known facts about the galaxy. Let's see what we can learn tonight, because that's what it's all about. It's about expanding knowledge, it's about enjoying the views that the universe has to offer to us, and understanding our place in the wider universe. Okay. The interaction with the smaller galaxy, which is NGC 5195, may trigger supernovae. The gravitational interaction between M51 and its companion is compressing gas in the spiral arms, potentially increasing the rate of massive starbursts. Okay, there you are. Black hole at the centre, and that's not uncommon for large galaxies. So it was the site of one of the most detailed Type 2 supernova. In 2005, a supernova was detected in M51, and there was a core collapse. So the core of a star just collapsed in on itself, and then boom. See where we're getting with this. There we are. I mean, we really are beginning to see a clear image of it, and that's just 5 minutes 40 seconds in. And it will, and when the software in the telescope is stacking, if it sees star trails, or if it sees things like trails from planes, or even from satellites, it'll discard the image. So you won't have that spoiling any images you make. And you see things like AI denoise, so you can actually take out a lot of the noise. Now that will probably not make it quite as sharp, but these are tools you can play around with, and it's that you can actually bring it all into your own PC or your Mac, whatever you have, and knock yourself out and learn about astrophotography the hard way. You know, with using all the different programs that are out there to bring the images in, sharpen the images, take out a lot of the guff that's there. But I say, this suits me. This really does suit me, because I just can't be bothered with the flapping about. I just want to see the universe around me, and I think it's a great way. I did pick up a second-hand solar telescope that I've been using very recently, and I'm loving that. I'm seeing views of the sun that I've never seen before. Again, from my own backyard. That's a Lunt 50mm, and you'll see, just check out the videos and the live streams. Once the moon is back up in the sky later, we will do a moon video, and we'll look at some of the craters of the moon. I mean, my goodness me, some of those craters are spectacular in their own right. So we'll do that as well. So what we're going to do, I'm going to just pause this. I think that's demonstrated what I can do with the M51. So I have a number of screens open here, so I'm jumping through hoops. Okay, so we get the gist, the M51, good. So if I'm just going to, now that I finish this last, but two galaxies merging. Now they say that Andromeda and the Milky Way is going to merge at some point. What's interesting about that, the idea of merging. Oh, there's a streak there. Sometimes software kicks that out. They say that because the space between stars is so immense, that even if Andromeda and Milky Way do merge, the damage it will probably cause to the individual stars and systems is going to be that great. And that's one thing we don't always remember about space. Space is big. The distance between stars is immense. You go back to Star Wars as a good example, Empire Strikes Back, and you have the Millennium Falcon going through the asteroid belt. That is not what an asteroid belt looks like. You go through an asteroid belt, you see an asteroid every 100 kilometers or something like that. It's not space is not as compact as movies make out. Okay. So we're going to end this. Thanks very much, little telescope. There we go. I mean, I think that's great. I'm going to click on AI diagnosis just to see what it does. Let's see if it does anything. Yeah, we won't be here to see it. It's a bit like the when the sun begins to end its reign. We won't be here there. And again, one thing you can do, take that image into Photoshop. I have it darken, obviously, where space is, but I think that's great. And I think just to garner your interest in astronomy in general, I think that's fantastic. I think this is a very good tool to pick up and go. And each one of those stars is a star which may have a system around it. And this is a great thing. You can begin to learn so much about not just the big things in the galaxy in terms of these any of the universe, not in terms of these galaxies, but the smaller ones, individual stars that could have solar systems around it, and who knows, is there life? So let me I'm going to go back out of here into the main screen. Let's see what else it's given us. So, oh, I've never seen this one. The Blowdryer Galaxy. Will we have a go? Let's have a go. While it's trying to find it, I will. Never heard of it, I can honestly say. Okay, I've typed in the Blowdryer Galaxy and it's giving me images of blow dryers. There you are. Where's ChatGPT when you need it? Where's ChatGPT? I was hoping to do. Oh, there it is there. Okay, what do you know about the blow dryer? Well, I am farting about here, trying to bring things up. You may tell me what you know about it. Let's see hopefully it finds it. I'm quite interested now in the Blowdryer Galaxy. What I'm going to do is, while that is loading, I am out of a beverage, so I'm going to get a beverage. I really should have muted that before you hear me swallow half a glass of vodka. Okay, I'm back. What did I miss? The Blowdryer Galaxy. Well, it'll be interesting to see. Now, this is about, I think, 55 million light years away. And again, this just shows you the distance when we talk about space travel. There's nothing close to us. Once you go outside the solar system, what's the nearest star? 4 light years away or something, yeah. So you're not going to get anywhere in a hurry. I mean, there's Voyager, that has been going for 40 years and just left the solar system. I think, was it last year or year before? The idea of faster than light travel or warp speed is always the the promise that makes space accessible, but it is, unfortunately, it does live in the realms of fantasy unless you can find something like a wormhole or create a wormhole that's going to be able to join two different points of space together. Unfortunately, a lot, and this is when we talk about aliens, unless they've done something to the laws of physics, you cannot change the laws of physics, as someone used to say. It's another reason why, sadly, the idea of aliens is probably, well, certainly aliens arriving on Earth. There may be alien life out there somewhere, but for them to travel the vast distances, it would require something that we can't fathom. But then again, 200 years ago, we couldn't fathom how to fly. It's not impossible, it's just highly unlikely. So we're sitting here watching for the Blowdryer. Oh look, I'm going to scroll, sorry. I got very excited there for a moment. So I'm going to scroll up here. This is what I get excited about. So there's another little galaxy. And this is what I like about, when you look at the Hubble images or the James Webb Telescope images, and they're showing you one of the wide field photos, and you're seeing not one, not two, not 10, not sometimes hundreds of galaxies all at once. Fantastic. And there are trillions of galaxies, billions of trillions of stars, billions and billions of trillions and billions of solar systems out there. So the idea that there isn't life, it's hard to grasp now. Is it life that has evolved in some way? Again, that's another thing. Just life can take on many different, it could be just plant life, it could be life in the sea, it could be bugs, it could be anything. To get intelligent life, as we would interpret intelligent life, what are the chances of that? And what is, and even one of the things we're actually quite lucky with, if Earth had been, I think, 10 or 20% denser than it is, space travel in itself would be almost impossible for us, because the amount of energy you would need to lift off the Earth and to keep you in orbit until they break orbit would be quite staggering. So we are fortunate, and we really are in the Goldilocks spot. Okay, this isn't as clear, but again, it depends on the size of the galaxy. It also, when you're doing astrophotography, it depends on what's called seeing, the conditions of the night sky, and also the surrounding light. I'm not too bad here, I must admit, compared to some places, but there's a lot of factors you have to factor in when you're doing astrophotography, and this is another reason why the SEESTAR S50 is the great. And I bought this myself. I'm not in any way connected with CW, with CW, whatever they call themselves. This came out of my own pocket, and I am genuinely, truly impressed with a 50mm focal lens with a 250 millimeter focal length and think blah blah blah. Really, this things can used to lift it and go. That is the most amazing thing about it. There's no problem with it. And, I do have a 10-inch Dobsonian. I very rarely use it. It's simply because it breaks my back having to lift it in and out. It's a great telescope, particularly for viewing. I love using it to view the moon, and it does need a bit of a clean, so it's going to be a bit the mirror on it, but we'll do that. We will get it back up and running for the winter months. We'll get some moon viewing, because the moon is in itself. I get to look at the moon for hours. I think each crater is just has its own story to tell. But anyway, okay, so we've spent 5 minutes on this. We can begin to see, but again, the telescope is not the be all and end all. It's a jumping off base, and that's what's all astrophotography. This is so you can learn more about the universe around you, and so let's learn more. So let's learn about M100, Messier 100, or the Blowdryer Galaxy. Why the nickname? Why is it called the Blowdryer Galaxy? Now, it's not an official name for the galaxy. It's a colloquial name, and it's used by amateur astronomers and astrophotographers, and in certain images apparently it resembles a blow dryer. Yeah, I don't know. I think what I'll do, actually, I'm going to see if I can find an image of the blow dryer galaxy that makes you think it's a blow dryer galaxy. Let's see if we can images. Yeah. I mean, I'm looking at it. I'm going to be honest with you. I don't see a blow dryer. Maybe it's just me. I do want to know what that little galaxy is to the bottom. Give me a second here, see if I can find out what that is. It's quite interesting. Blah blah blah. Come on. It's in the Virgo cluster. It has a diameter of 166,000 light years. And proper terminology is brightness, well-defined structure, blah blah blah. Let me ask ChatGPT, what is now the smaller galaxy, according to ChatGPT, and who am I to argue with that? And it's beginning to take shape now, actually. Yeah, this one just taking a bit longer. So that's smaller, little one there. That apparently is NGC 4323. Make it so. It's a dwarf elliptical or irregular galaxy. It's roughly the same distance away, about 55 million light years. And they think it's that smaller galaxy is actually gravitationally bound to the Blowdryer galaxy. Not bad. Now, another thing you can do with the S50, in particular in equatorial mode, is you actually do mosaics. So you could set this up and get a larger wide field image as well. Okay, so we've been at 6 minutes. I'm just going to call that a day, and we'll see what else is out there. While we're here, oh, it's gone. So, stargazing. Let's see what we got. The Cigar Galaxy. Give me lots of galaxies. Let me see if there's any nebula. There's one there, a nebula. The Aris Nebula. Shall we see what's happening with Aris? We will indeed. just Google for some facts about the Iris Nebula. See what it comes up with. So, I say all SEESTAR needs to do is come up with a program that is properly integrated into Windows, and that will make my day. You do have to do some flapping about, and I probably will do a program, a video on how to integrate it into your PC, simply because it means you can sit with a big screen in front of you and knock yourself out rather than a tiny phone. I'm not stacking the image myself. I'm just going to do everything in the telescope, and I'll tell you why, Judy, I just cannot be bothered. I've tried astrophotography in the past. I got frustrated because obviously, it doesn't take much to screw up images, whether that if your telescope's not properly calibrated, or if you're slightly out of focus, or if you get star trail, blah blah blah, and then you have to bring it all into your PC and then start working on it. So this suits me. This is great. You're not going to obviously get the same quality of image, but to me it's more than just the images. The images are just a starting point. This is where you begin to learn about the universe around you, and the images are there to inspire you to learn about everything that's going on. Listen, go on to Facebook, find the SEESTAR groups, find the SWO official group, and you will see some stunning images where people have taken the individual photos and brought them in and done their own stacking, and fantastic. I just can't be bothered by it. I just like this. I let the computer do all the work. I am lazy and I don't care. This is just wonderful for me, and I could sit and actually watch it build up image by image by image by image, and that would suit me greatly. Let me see if I can so we're going full screen mode. Basically it turns off all the guff around it, but it still continues to stack, I think. Maybe not actually. Oh no, it does, yeah. No, there's a timer at the top of the screen that you can't see. It just seemed to freeze, but it's continuing on. Yeah, so we're 1 minute 10 seconds, and this is for the Cigar Galaxy. Oh no, it's not actually the Cigar Galaxy, I'm telling lies. This is the Iris Nebula, and its official catalogue name is NGC 7023. Great starship, NGC 7023. And it actually refers to the star cluster inside the nebula, and it's a surrounding reflection nebula, and it's part of a larger dust cloud. So it shines not because its own, the nebula itself isn't shining because of its own inherent light, and it's not hot, it's not emitting a light of its own, but it actually reflects the light of a nearby star, and that's why it's so called a reflection nebula, and often it would appear blue. So in the same way, actually it's quite interesting because it's kind of like the way we have blue sky, and the way that light is scattered in the atmosphere. This is what's happening here. The light from the stars being scattered in all the dust of the nebula. Here's an interesting one, and I remember reading it somewhere for the Star Trek fans. Star Trek 2. I can't remember the name of the nebula. I should know the name of the nebula, where Khan and Kirk had the final confrontation. But apparently if you were in a nebula, you would not know you're in a nebula. Again, it's the difference between movie land and real life. The dust and everything that's in the nebula is so far apart. If you were inside it, it would actually quite look like normal sky, as well as we know it. So there you go. Throw it out there. You can disagree as you like, and also if you can think of the name of the nebula that they entered in Wrath Khan, throw it in the comments. So the star that's illuminating the Iris Nebula is named HD 200775, and it's about 10 times more massive than the Sun, and it's still forming. It's just quite a young star. So it's only at the beginning of its life. So it's about 1,300 light years away from Earth. Again, just show you, even traveling at the speed of light, what you can't do, it's going to take you over 1,000 years to get here, and a 6 light years across. Okay, a rough maths question, and this is maths, not math, but anyway. So it's 6 light years across in terms of miles, and I'll also throw in kilometers just for the heck of it. What is that in miles and kilometers? 6 light years across. I know the answer because it's right in front of me. Oh, there we go. We're getting there nicely. Yeah, don't forget to, I might as well throw it in here, like, follow, blah, blah, blah. If you want to support us, you can do it through Super Chat. You can become a member. Blah, da, 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 da. We really do need your support. Any revenue comes in this is really just from ads. Yeah, I like that. I say probably the most well-known nebula that we know is the Orion Nebula, which is out of our sky at the moment. That's heading south to Australia and beyond. G'day. I'm not exactly sure where you'll want to see it in the world, but we won't see it again. It's probably October, September, October time. But I did take a photo. Funny enough, I did take a photo of it. Well, if I can find it, it's on one of the rare occasions where I was taking photos with my main scope. It was only a 30-second capture. I was quite pleased that it's not far from perfect, but yeah, I can't find it unfortunately. And I did have it tied up to a micro 3/4, 2/3, whatever it is. Camera. Where did that go? I was quite pleased with it. I actually thought, oh, that's not bad going. Document. If you're trying to find anything, when you would need to find it, pin yours. Blah, 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 blah. Nah, I can't find it, sadly. I can guarantee you once this stream is over, it'll pop up and yeah. But anyway, so there we are. Okay, that's the Iris Nebula. Taking a while to form, but we're getting there. So what we're going to pop, we'll just bring that to the end. That's 6 minutes, so we've done quite more than that. And again, if you're doing this properly, you probably need to set this up for hours. You know, we're only doing a few minutes, which is fine. Let's see if we can denoise it. But really, to get the most out of it, if you really want the best images, set up for hours. You do have to get it on an equatorial mount, so it is aligned to whatever part of the world you're on, so you're looking more or less like the North Star. There you go, very fuzzy. And you can see right at the heart of it, the young star, this big beating and forming and growing and throwing out light and everything else that comes with it. Okay, let's see what we got here. So we'll go back into stargazing, and we're not, if you like, telling it where to go. We're just using its suggestions at the moment. We can do the Pinwheel Galaxy, There's Nebula. So I'll throw a couple of options out here. So you have a Spiral Galaxy, Pinwheel Galaxy, Cigar Galaxy, or Bode's Galaxy. Oh, and also the Beehive cluster. Now, this is the best right now, but the software is telling us. So, if you have any particular suggestions, suggest away. What should we do? Do you want to go for a cluster, or do you want to go for a galaxy? I've just been thinking, I hope I turned the mic back on when I'm just sitting talking to myself. So we will then, so far, I will go for the Beehive Galaxy. Beehive cluster, sorry. Beehive. So I was going to try and find, and this is great. I mean, this machine knows exactly where it is. It knows where to point to. There's a reason they call smart telescopes, because they are damn smart. And there it is, chugging along without any help from me. I don't need to do anything about it. So I was trying to find M44, the Beehive cluster. So let's see if it's found it. Okay, it's moving through the sky. Oh, it must have found it. There we go. Well done. Okay, we'll go for the screen, take off all the guff around the screen, and we'll see what we got on it. Okay, Beehive cluster. Who knows the Messier classification for it? 10 points for anybody who can tell me the Messier classification for it. A lot of satellite streaks going through there. I'm assuming there's satellite streaks. It's a bit rude. Yeah, and you can see that the software's rejecting a lot of that because it doesn't like them. And again, it's smart. It knows that what to look out for, and even things like star trails. If you just set a camera up and take a photo of the sky and leave it going for say for 30 seconds, the stars will begin to leave the trails up because Earth is turning against the night sky. So it creates a trail automatically. That's why if you go into equatorial mode, as it's known, it all compensates for the spin of the Earth. So it's not quite as bad. So let's see, so Beehive cluster. Oh, okay, so the reason it's called the Beehive cluster, which is M44, and you're all very quiet, it's annoying me. If you would speak up, just hit that chat button and say something to me, so I'm not alone talking to myself like a crazy person. Where are you all from, by the way? I'm assuming you're from different parts of the world. Let me know in the comments where you're from, please. So, back to the Beehive cluster. The reason it's named the Beehive cluster is because a lot of people, when they were initially viewing it with the small telescopes, and it looked like a swarm of stars, like a buzzing beehive. So there you go. It's an open cluster. That means it's a loose group of stars that were born from the same gas cloud and are gravitationally linked. Supernovas are odd things because you don't know when they're going to happen. So you need to be viewing, say, a galaxy, and you might see a part of it lighting up brighter than it normally does, and that's how you would observe a supernova. So sadly, I mean, it has been observed. If you what was it? The Whirlpool Galaxy, I think there was one observed there. There's no way you can set your watch by it, unfortunately. If you can see it, you're very lucky to see it. They say they do say Betelgeuse could go supernova. That could happen at any point within the next 100,000 years, or even a million years. We just generally don't know. We're guessing. So I've seen a lot of stories that say, "Oh, Betelgeuse is going to go supernova in the next few years." Don't hold your breath. Please don't, because there's no guarantee at all that that's going to happen. So you're looking at stars that are 577 light years away from Earth. So again, the great thing about astronomy is not only are you observing the the universe around you, you're actually time traveling. So this is how these stars looked 577 years ago. So if any of them have gone supernova, we won't know about it just yet, because light will take 577 years to travel from there to here. So this is probably one of the closest open clusters of stars to Earth, and it's in the constellation of Cancer. Now, if you can find a really dark sky, a lot of this will be not kind of visible to the. I mean, this one will see with it like a fuzzy cloud. But we are cursed. Obviously, like, everybody needs light and electricity, but it does make stargazing so much more difficult. And again, this is another reason why I love this telescope. I can point and shoot. I don't have to worry really too much about the light around me, the light pollution. It kind of it does a good job of taking care of that. So although it's not visible from here, the actual Beehive cluster contains over 1,000 stars. Many of them are actually like our own sun. So if we are studying stellar evolution and how stars form and grow and develop, I think this isn't a bad place to look when you're trying to find out a bit more about our own sun. And in recent years, astronomers have found some exoplanets. Now, the Beehive cluster, they think, is about 600 million years old. That makes it older than the Pleiades cluster. Now, Pleiades, again, we're too late for that. The Seven Sisters, tied to the Orion constellation. Well, that's another thing we're going to do a video on. How these stars actually got their name, like the Pleiades and Orion, the Hunter and the Seven Sisters. Great stories behind those. But this one is thought to be about 100. Pleiades is thought to be about 100 million years old, and the Beehive cluster is 600 million years old, actually. In which case, we are seeing it not long after it began to form. You know, if it's 577 million light years away, sorry, it's 577 light years away, so we're not seeing it that closely. And the Beehive cluster was also known to Greek and Roman astronomers. And it's best viewed in spring, so we're right on the ball here. And because it lies in the constellation of Cancer, it's part of the zodiac, if you're into that sort of nonsense. So, I suppose if they're only 600 million years old, yeah, they are quite young stars. They've billions of years ahead of them. And there's been planets found around some of them. So a whole area of life. Interstellar life, solar life, planetary life, all there, of different sorts. And nothing beats having a telescope, I must admit, and seeing things through it. This is probably the next best thing, sitting in your own house on a big screen, watching these things take shape in front of you, learning about them, and learning our place in the universe. That the sun, our star, is actually quite an ordinary star. There's nothing overly special about it. You know, our sun isn't even going to go supernova when the time comes in a few billion years, because it's not big enough. It'll turn into a red giant, expand, it'll lose its outer layers, it'll become a nebula in itself, and then this core will collapse to be a white dwarf. That's a few years down the road, don't worry about that. All these stars have their own story, have their own surroundings, have their own neighbourhood, have their own planets that are close to them, and who knows what's out there. And one day, there may be a way found to be able to get these places in certain years, if not millions of years that we're talking about now. Okay, we're going to go back to the main screen. I think we have to end this one. Sorry about that. Okay. Stargazing. Let's see what we've got. So we'll go to Bode Galaxy. Okay, so who is Bode's galaxy named after? Don't say Bode, because that's just cheating. Yeah, we are pale blue dot, and that's all we are. You know, we are nothing special. And it's almost a depressing thought, but it's not a depressing thought. We are nothing special in the universe. We're one planet among trillions out there. But here's one thing, and it's actually indisputable. In this part of the galaxy, in this part of the universe, this is the only place that we know of, we can put money on, that there is life, and certainly intelligent life as we know it. So that's why, in that sense, we are special. As far as we know, life only exists here. Nowhere else. And that's nothing to do with religion, nothing to do, that's just scientific fact. And again, going back to what I said earlier, if there is other life forms out there, we don't know what stage of evolution they're at, we don't know where they are, we don't know whether they're plant life, gaseous life, or some sort of life we haven't comprehended before. This type of, again, not even the physical side, but intelligent life, that may not exist anywhere else, not in the galaxy, in the universe, simply because the conditions may not be right. We're actually quite fortunate that things fell into place the way they did to allow us to evolve into what we are today. So yes, we are only one planet, one pale blue dot amongst hundreds of millions of other pale blue dots, red dots, green dots, pink dots out there. But we're the only one that we know where there is life, and that in itself is something that's worth remembering and preserving, and obviously, and looking to the future and how is this life preserved for everyone, and do we take this life into the universe, into the galaxy, into the solar, further into the solar system, because humans have always been explorers. It was humans always decided to see what was beyond their cave, what was beyond their field, what was beyond their city. What's next? And that desire for exploration that has inspired us to become technologically advanced. And let's forming out quite nicely like this. So let's find out about Bode Galaxy. So given you're all very lazy and not one of you has found out who it's named after, it is named after Johann Albert Bode. He's a German astronomer who discovered it in 1774, and it was later, oh excuse me, sorry, it's almost midnight here, Charles Messier's catalogue as M81. And it's a grand design spiral galaxy because it represents a textbook spiral design. It has well-defined spiral arms. This becomes very clear in telescopes. And it's located in Ursa Major, not far from the Big Dipper. So how far is it from Earth? I'm glad you asked. It is 12 million light years. And again, this is why it's staggering. Not 12 light years, 12 million light years. So if by any chance we discovered the ability to go as fast as light, it would still take us 12 million light years to get there. And that's actually quite close in cosmic standards, it really is. So it's part of a larger group called the M81 group. It's a bit like a pop band. And the wider group also has things like the Cigar Galaxy and about 30 other galaxies. Apparently it had a supernova in 1993. And again, you only find this out by, there are astronomers who are watching these things on a very regular basis, and when you compare one set of data to another set of data, then you begin to notice, oh, that's a little brighter than it was 3 weeks ago. What's happened? So the arms, which you can just see begin to form there, it is full of young blue stars, pink nebulae and dust lanes. So it is again very active. It's a galaxy is very much alive. Galaxy that's breeding new stars and new planets, and it does interact gravitationally with the Cigar Galaxy. I'm just reading what it says. It causes gas bridges and tidal distortion. I'm going to have to look into that more detail. Sounds very interesting. But that which become visible in radio wavelengths. And again, that's something else. We're looking at a visible spectrum, but there's also many different ways to observe the universe, and radio is another way. Oh, Hubble and James Webb have looked at it. Let's see what Hubble has come up with. Oh. I like that. Let's save that. we'll have a look at that. So I'm just going to load up a Hubble image, because you can't beat a bit of Hubble. So this is Hubble's view of what we're looking at. And again, you know, you can't compare the two. Don't try and compare the two. You know, we're starting with a 50mm telescope, a 2-inch telescope, which I think is doing a fabulous job. You know, Hubble, of course, is many times greater than that, and also outside Earth's atmosphere, so it doesn't have all the distortions and all the distractions that you have to put up with. But I'm loving it. I really am loving it. The galaxies really do come up well. You know, and at the heart of it is a black hole pulsating away as everything spins around it. But like our own Milky Way, well, we're just a very small part of it all. It'll take about 250 million years for us to go around our own galaxy just once. Yeah, well, like, Linda, there are telescopes out there who do view the nebula in different light waves, and that's what it's all about. You know, there's ones that view it, and that's why some of the images in Hubble, they're not what you would see through the naked eye, but they attribute colour to different gases. So a different gas for hydrogen, a different gas for nitrogen, things like that. So Bode's galaxy is about 90,000 light years across, and the Milky Way is about 100 to 120,000 light years across. It's roughly, we're talking about the same amount of stars. We can't be exact, of course, but the Bode's galaxy has around up to it's thought has up to 300 billion stars. The Milky Way could have up to 400 billion, but think about it, 400 billion stars in one galaxy, and as we know, there are trillions of galaxies. Oh, well, that's quite interesting. The black hole in Bode's galaxy is around 70 million solar masses, so you're taking our sun 70 million times the mass is what's at the centre of Bode's galaxy. Our black hole is quite sparse compared to it. It's 4 million solar masses, so when you see it up, I think that's coming along fabulous. It really is. I really like that. Actually reminds me of the Andromeda Galaxy. You're right. Abraham, Samuel, compared to other stars, I say Betelgeuse is a very good example. Betelgeuse would, its diameter reach out to Jupiter. However, Little Sol, our star, is the only star that we are aware of that has a planet that surrounds it that has life. So, we are insignificant in so many ways in the universe, but that one thing, as far as we know, We are the only planet with life anywhere. And we can hypothesize, we can guess, we can come up with theories as to what we think is life out there, but one thing we know is as far as that life is here, and we haven't discovered life, and certainly not intelligent life as we would define it anywhere else, which is great. Hello Japan, hello Karina, Antrana, Linda, Abraham, hello everybody. So we're looking at Bode's galaxy. And it's about 12 million light years away from Earth. So if you are just thinking of going there, you need to leave now before it gets too dark. So we're doing this is with the SEESTAR S50 telescope. The SEESTAR is an all-in-one smart telescope. It is a telescope that not only takes pictures, but I will actually begin to stack those pictures for you so you get the best image. You don't have to do anything else. Now, if you wish, you can take those individual images, bring them into your PC, and play with them to your heart's content. I can't be bothered with that. I just want something that I can plant down and just let it run. And this is what pleases me. Watching the universe around me from the comfort of my own home. It is laziness, but it's great. Okay, so we've done it for quite a bit. So almost 10 minutes, so I'm quite pleased with that. So I'm going to denoise this. This will take out a lot of the spackly side of things that you'll see in these type of images. But again, I would encourage you, go onto Facebook, look up the CWO SEESTAR. There's a couple of different SEESTAR groups, and there you go, that's lovely. And again, look at each star around it. Each star has a story to tell. Each star has, the majority of stars is thought to have some sort of planetary system. In fact, a lot of stars out there are actually double stars. They're not just single. They're binary stars. We're actually one of the, I think we're in the minority having a single star. Okay, so we're going to flip back. Let's see what else we can find tonight. Let's push it to its limits. Oh, we still have to, it's chugging away there. Let's see. We'll see if we can find a comet. Current, yeah. So there's only one, P2010. Never heard of it, but hey, never let that stop us. Let's see if I can find it. And again, a lot of this is going to depend on where you live. Yeah, I'm surrounded by houses and trees and things, so probably my view of the night sky is going to be somewhat limited. You may be lucky, maybe you live in an open field and you've got the whole night sky to yourself. Good for you. But we'll see. But again, this telescope just does it all. Just point and shoot. You don't have to worry about anything. Just sit in your house, stick us on your big TV, and away you go. But SEESTAR, you need to sort out an app for the PC. Because there's a lot of workarounds, but it's a pain in the backside. Make it easier to put this on your PC. We will definitely do a night of lunar astronomy where we'll just sit and look at the moon, and I could sit and look at the moon all night, I don't care. Each crater, each sea is its own story to tell, its own history, and it's obviously very much connected to the history of this planet. The main theory being that the moon is part of Earth, and another planet that collided billions of years ago during Earth's formative years. Well, Abraham, where would you go? You have a whole universe out there. What tickles your fancy? Is it the Andromeda Galaxy? Is it the Orion Nebula? Where would you go? So So when we're trying to find a comet here, comets are actually quite, mainly because they're actually quite small. Now if they're close enough they will give off a tail, and that's what we're looking for. The tail is the giveaway. Otherwise it probably just looks like a star. Let's see what we can find. I don't see anything yet. I'm not exactly sure where. Usually it's in the center of the screen, but so far nothing. Let me see what I can find. Yeah, I'm just having a hard time to find it. So what we're looking for is P2010. I'm gonna ask Mr. ChatGPT about that. I don't think we're going to have much luck. Now, I have taken photographs of a couple of comets. The one back in 2021. I've got a lovely photo about that. I'll find out for the next go. And the one that was recently, I've got a photo of that. So yeah, comets are cool if they're visible. So where are we here? So apparently P2010, this comet that we're trying to find, is a fascinating object that blurs the lines between asteroids and comets. It initially appeared comet-like due to its tail, but was later identified as an asteroid exhibiting unusual behaviour. Oh. So subsequent observations, particularly from Hubble, revealed that the tail was not due to typical cometary activity, like the sublimation of ices, which, if they head towards the sun, they melt and leave it above, but as a result of a collision between two asteroids. Oh, that nice scene. I'd love to see that. Two asteroids colliding, who wouldn't? And the primary body is about 120 to 150 meters in diameter. My goodness me, we're not going to really see too much here. We really aren't. We're talking about things that are in the scale of astronomy minuscule. But we'll let it fire for a few minutes, see what it comes up with. But that's what we're looking for, a tail. That's the giveaway sign. And there is something there in the middle, I don't know if that's it. Now there is a program for the PC, I think it's called SEESTAR ALP. I think you need to be into Python to get it to run, but I'm going to look into that. I think it works with Stellarium, which, if you haven't used that, is a good program for looking at the night sky and seeing what's out there, where you can actually almost point and click. So I'll look into that for the next time. Okay, so I don't think that's working. So let me just end that. Which is unfortunate, but... I'm not sure what's going on here. I may have broken it. Right, so we'll go back to stargazing. Let's see what else. What a more Jupiter, Mars, current altitude. 5 degrees, that's very low. Did we look at the Pinwheel? I don't believe we did look at the Pinwheel Galaxy. Let's see what the Pinwheel Galaxy M101 has got for us. Another galaxy. Great thing about galaxies is that they are very good to view. Even with a normal telescope, we're seeing Andromeda doing a telescope, fantastic. So let's see what's out there, shall we? Yes, good crack. What we can do also some night, particularly, and you can guarantee the clouds are going to roll in any time here, is some sort of virtual astronomy. I'm going to use Stellarium for that. And again, you're not tied to what you can and can't see. It's just obviously all on the PC. But again, it's all about learning. It's all about expanding your knowledge of what the universe is around you. Oh, and almost straight away we have a fuzzy dot. And this is the Pinwheel Galaxy, simply because it looks like a pinwheel. I do wonder, I don't know if you can turn off. Obviously it compensates for star trails, so if you're taking too long an exposure, it won't incorporate anything that's star trail, but it's fair enough. But I wonder if you can turn it off, simply to be a bit arty-farty and create an image with star trails. I'll look into that. But the system itself, I can't complain. I think it's very user-friendly. The SEESTAR, I think the apps I've used in both Android and iOS both seem to work perfectly fine. No problems with it. The only problem I have with the software is that there's nothing dedicated for Windows. And I would love to have the app tied into Windows. So rather than, and it can be done. You can find ways around to connect your phone. And that's what I'm doing tonight. This is what you're seeing on screen is my phone being projected on into Windows, and then iOS OBS blah blah blah. It's a workaround which works, but it is a pain in the backside. So there we go. We've got the Pinwheel Galaxy, which is another grand design spiral galaxy. So it means that the features of the galaxy are very prominent. So you've got nice defined spiral arms that extend clearly from the centre. It's an Ursa Major, and it's near the handle of the Big Dipper, and it's like 21 million light years away from Earth. So remember, when you see stars at night, every star you see is within the Milky Way. You know, if you are lucky to see a galaxy, and particularly Andromeda, which you can see in this dark enough area, a lot of it will seem like a fuzzy blur. But if you were looking at stars, every one you see in the night sky is within their own galaxy. It's actually, now the Pinwheel Galaxy, it's actually bigger than the real Milky Way, which is quite rude. How dare they? And has a diameter of around 170,000 light years, which is almost twice the size of our own galaxy. So it's one of the largest nearby galaxies that we're aware of. And who discovered it? So that's a wee quiz for you. Who discovered the Pinwheel Galaxy? Knock yourselves out. And there's a prize of a big hurrah if you get it. Yeah, don't forget to like, follow, subscribe, blah blah blah. You know the score. Also support us on the super chat thingy, my bobber. It all helps to keep us going. Yeah, as you can see the screen, we have on the channel work as this is the first night. So on the right hand screen, you got me. Down here in the bottom, you got me. Yeah, thinking the space above me. Do I put some text of what we're looking at? Blah blah blah. Any ideas, just put it in the comments below, which would be good. So this is forming up nicely, and even now you can see the spiral arms taking shape. I mean, this wee telescope it does cost quite a bit. I think about £500, but given you can spend that on a mount alone, I think it's very well worth the money. Again, you have to manage your expectations. So you're never going to get the images with this that you will get with a 8-inch telescope. It's never going to happen. 6-inch telescope never will happen because you're working with a 2-inch telescope. It's just the reality with it. But it takes out a lot of the hassle. You're not lugging about a heavy amount. You're not lugging about a heavy scope. You're not lugging about an extra camera. You're not getting everything lined up correctly. And that's what you always have to factor in. And that's one thing, the reason that I get so sickened with astrophotography, that it's like a chore, having to get everything set up, having to make sure everything was equal, set up correctly, and the camera, everything was balanced, and what was very frustrating when you thought everything was balanced and you thought everything was set up, and even then you couldn't even get maybe a 20-second exposure because they were started early. Very frustrating. But this just takes the hassle out of it. And again, check out those Facebook groups for this kind. You will see some stunning images that can be achieved with this if you want to put the effort in. At the moment, I'm happy enough for what I get. I'm happy enough to sit and watch these images take shape. I mean, I could sit and let this run for the next 3 hours and then come back, and then there you go. The system is set up for that. Now, the way the SEESTAR works is that once you charge it, it'll probably last about 6 hours. You can't actually connect it up to I suppose you could connect it up to an electric charger, but if you're doing anything overnight, just to be sure, I would probably put an extra battery with it. You get tape it onto the leg of a tripod or something and run a cable up. But the tripod I have is fairly sturdy, but it weighs a fraction of the tripod for like an EQ5 or EQ6 mount, which you would use with that larger telescope. Look at this, you can see the trailing arm. And that's just 4 minutes. I mean, again, if you were to let this run for an hour, you'd have a great image. And the whole point of this is about expanding your knowledge. This is about enticing you to learn more about the universe around you. Cheers, big ears. And that's another, yes, I don't know if you, that little warning popped up on your screen, but it says star trails was detected, so the computer system within the telescope will reject images that it doesn't think is good enough quality. You don't even have to worry about that. You can just sit back and let the universe unfold around you from the comfort of your home. Say, you can do it on your phone, you can do it on a tablet. I just wish there was a proper program to do it on a PC. It does work the way I'm doing it, just a bit of flapping about. So that is kind of, when you are using it on your phone, you're kind of getting a very wide angle view of things. But you could turn it around and I don't know if I could do that. Rotate counterclockwise. I don't know if that's any better. But you really can begin to make out the spiral arms without any shadow of a doubt. and obviously the centre of the galaxy there. And it's 5 minutes, just 5 minutes, which I think is quite extraordinary. And this is being fed through OBS. I wonder if I can. I'm just going to mess around with some of the filters in OBS just to. I'm going to make it a bit darker. Myself before. So it's just lightness and darkness. You can also add a sharpen filter. This may make things even worse, but so. Yeah, we'll leave that off. I don't know, but I am very impressed with this little machine can do. All within the size of a large cereal box, or shoe box probably, would be a better comparison. And you're not struggling to lift it in or out. As long as you get a relatively good enough tripod you're flying. So as you can see there, was just the added effects I added in OBS just to darken the surrounding space. I think it adds a bit of a punch to the overall image. Again, once the thing's finished, you can use the inbuilt settings. We'll end it here and we'll see what it is, because you can actually add there's different adjustments you can add yourself, blah blah blah. It's not super do much, but anyway. Oh, there you go. So one of the things that I'm going to use is the AI denoise. So let's see what it comes up with. Well, it's getting towards midnight here, but now it's for about an hour and a half, maybe 2 hours now. I've enjoyed it. It's been very interesting, and I'm going to do more of these. It's all about expanding and enhancing our knowledge of the universe around us. And if you can think of things you want to see that we should focus on, drop me in the comments or whatever. We're in the northern hemisphere, so if you're from Australia, unfortunately we can't help you. But you're free to tag along. But there's a wonder, you know, and it's not just the galaxies, there's stars, you know, and stars in themselves have their own story to tell. And we, you know, I want to explore that too. And I think that's come up actually quite nice. You know, that is just 6 minutes. You would never get that in real life. If you were, you know, for 6 minutes, that's hard, you know, it's hard to beat. I'm very pleased with it. So we'll do one final object for tonight. Everything's going a bit slanted because I turn things sideways. Did I turn it off? Yeah, I turned it off. Okay, so where will we go? Let's see. $2 far too low. We need something a bit higher up. I don't know if it's going to be able to see a lot of these, unfortunately. 27 degrees. 32. Let's have a look at this. SH271. I don't even know what that is, but it looks pretty. So I'm going to hit Mr. ChatGPT. SH27. So again, I don't know if I'll be able to even find this, depending just my view of the night sky. That's always something you're going to think about where you are and surrounding trees, surrounding buildings. It's always going to limit as to what you can or cannot see. Well, it's fine something, so that's always good. So let's get back to OBS here. I want to take that off. So this is SH271. It's a planetary nebula, which means it's basically a glowing shell of gas ejected from a dying star. Basically, what's going to happen to our sun. So when time comes and our sun is no more, it's going to expand to become a red giant. It's going to expand point to where we are. But what will happen, all the outer layers of the sun will basically drift off and become a nebula. And at the heart of that nebula is going to be a white dwarf, which is going to be the remains of the star itself. So SH271 is in the constellation Aquila. And it's about quite interesting. The estimates are between 3,300 to 6,000 light years, so it's quite a bit of a gap. So it's what's known as a bipolar nebula, which means that gas and dust are ejected from opposite directions and forms an hourglass or butterfly shape, and could be a binary central star. Now what they say is that it's actually quite faint, so we're actually quite lucky to see any of it. And it's best to be seen in narrowband images, as when you restricted wavelengths that are coming through. So things like hydrogen alpha, so you can only see certain light waves that are, so you're limiting quite a bit of the spectrum. So the nebulous light comes from ionized gases, so it's hydrogen, oxygen, nitrogen, and the greenish blue glow is doubly ionized oxygen. There you go. And it's a remnant of a star like our sun. It's reached the end of its life. It's shed its outer layers, and the remaining core is going to cool into a white dwarf. So you're actually looking at our own future here. And that's what our own solar system is going to end up like. Let's finish it off for the night. Okay, I should stop that, I thought. So one more, let's see where we go over the bio. Done the Pinwheel, we've done the Whirlpool. With Neki 4, Sunflower Galaxy. A vacuum cleaner, brilliant. The Croc's Eye Galaxy, that sounds interesting. We did the Oil Nebula, why not? So this will be our last shot for the night. And we'll see where we get from here. So once it finds it, and there we go. So the Ion Nebula is apparently it's called that because of its appearance. It has two dark circular patches that apparently resemble owl's eyes. I don't know. It's it's a planetary nebula. So again, but like the sun, how our sun will end up, it's the expanding shell of gas from a dying star. Now, the thing about a planetary nebula is nothing to do with planets, so it is what it is. Actually, like a number of things tonight, it's an Ursa Major, not far from the Big Dipper. And discovered in 1781 by Pierre Michan and catalogued by Charles Messier in his famous list of non-comet celestial objects. It is approximately 2030 light years away, and it's roughly 2.4 light years across. Now, in real money, that's over 1 trillion miles in diameter. My goodness. And at the heart is a white dwarf. Very hot, very dense remnant of the original star. And again, that's what's going to happen to our sun. And we believe that it's been expanding for roughly 6,000 years. The dark areas is where it gets this name from, because it's meant to look like an oil. And these eyes are not holes, but they're actually regions within the nebula with lower gas density. So that's why they look darker, because there's less matter there. And again, for a 2-inch telescope, 15 millimeters, this is doing a cracker job, because this is actually quite faint in the scheme of things. Hello, Jao 516. Sorry if I'm mispronouncing your name. Oh, I speak English, unfortunately, no Portuguese. I wouldn't even attempt to try it. So it's quite nice, actually. I like the colour. So it's what we're saying. Obviously, it looks like a green ball. So that is coming from doubly ionized oxygen. So you have at the heart of this nebula, you have a white dwarf star, very hot, and it's emitting intense ultraviolet radiation. Now this UV radiation light, it ionizes the surrounding gas, so it's stripping out all of its electrons from all the atoms. Now, when these oxygen atoms recombine later, they emit light, and that light appears green to our eyes. And because oxygen dominates this nebula, it's why it's green. Other gases such as hydrogen would emit red. I suppose it's in a way a bit like the way we see green aurora, where the oxygen atoms become what they call excited, where they get extra energy, and then they release that energy as green light. In the oil nebula, that extra energy is coming from an ultraviolet light from the white dwarf, whereas ours is coming from charged particles from the sun. So it's this oxygen atoms emitting light as they receive this extra energy, and in the oil nebula it's from the white dwarf star. Oh yeah, it's beginning to, okay, I'll give it to them. I get why they see it's called the oil nebula now. I think that's quite cool. So I hope you find that interesting. So that's a couple of hours we've been exploring the universe around us. It's my first, now, apart from a couple of tests I've done with the SEESTAR, and that's the first main attempt I've had at anything more than a few minutes, so I'm quite pleased as to how it's held up. I would encourage you to go and find the Facebook groups, see what is possible with this telescope. Again, I am not connected with ZWO in any way. I bought this telescope myself. I owe them nothing, they owe me nothing. It is my honest opinion. I like that it's a pick up and go. It is a smart telescope. It does a lot of the work for you, and if your attitude is that you're not going to get a award winning images, that's not the point. But you are going to get very good images. Images that will open your mind to the universe around you, and that's what it's all about. It's about knowledge. It's about expanding your knowledge. It's about understanding how the universe around you works. It's about understanding our place in the universe around us, and it's just getting more information and knowing that there is wonders on your celestial doorstep, and this is just a tool to see some of those wonders. So yeah, get it, understand it, enjoy it. I hope you enjoyed that. We will be back. We'll do this another night, no problem at all. And hopefully we'll do one with the moon as well. I'll probably get the larger telescope out to do a lunar night. I want to have a look at some of those craters and find out a bit more of what's going on the surface of the moon. But thanks very much for joining me tonight. Please do like, follow, subscribe, blah blah blah. If you can support us, hit that super chat button, become a member, and I'm sorry, I'm just trying to let that run. So that's only 6 minutes we're running, and you can definitely see the dark patches within the nebula, and that's where it gets its name from, because it's meant to represent an oil. But I think for a 50mm telescope, it's a great job. Okay, so thanks very much, kids. Until next time, cheers.